Work with polynomials, and today we're going to talk about multiplying a polynomial by a monomial. So really nothing new, to be honest with you. We're going to use the distributive property, and then we're going to use what we know about combining like terms in order to simplify expressions as best that we can. So at the end of today's lesson, you should be able to multiply polynomials with a monomial. Remember, the prefix poly means many or some, and then a monomial is just one single term. All right, so we've got our first example. Again, we're going to use the distributive property to eliminate those parentheses, right? Because that's what we need to do in order to simplify it. So as you see here, I've got different colored arrows. We know that the distributive property says whatever's outside parentheses is going to go to everything inside the parentheses. So I'll give you just a quick minute to get that problem written down, and then we'll walk through simplifying it. Okay, so again, we're going to distribute. Distribute means to multiply. So I'm going to bring this gray box down. Now you'll see negative 6d to the third times 3d to the fourth. That's this white term. I'm just showing the distributive property. One thing to make sure that you're paying attention as you do this, anytime that there is a subtraction inside that algebraic expression, it is going to go along with the term, and you're going to treat it just like a negative. Okay, and then if there's a positive or plus in there, then the term is positive. Okay. Notice I also added in that imaginary 1 right here, just as a reminder. Okay, and then from here, once you've got that distribution, then you're just going to simplify it. Negative 6 times 3 is negative 18. And we already know that when you multiply by the same base, then you're going to add these exponents. So I'm going to do 3 plus 4, which gives me that 7. And I'm going to do 3 plus 3, which gave me the 6. And 3 plus, there's not one there. Remember, there's an imaginary 1 as the exponent there. So that's where the 4 is. And then negative 6 times 9 is negative 54. And then there's no d's with the 9, so then that term has the d third. Then what you do is you take a look at that line and you look to see if there are any additional like terms. So remember, the like term has to have not only the same base, meaning the same letter, they all have the same letter, but their exponents are different. So because their exponents are different, there isn't anything else that we can do to simplify this expression. Okay, so that would actually be your final answer, completely simplified with that one. Again, what did we do? Take whatever's outside parentheses and distribute it or multiply it with what's inside. Okay, before we take a look at the second example, what questions do you have on the first one? Things like, can you explain again why, or how come we needed to? Can you go over again how we, anything along those lines? All right, let's take a look at the next one. So if you would copy example number 2 down, we're going to walk through it step by step. Now notice this one isn't just simplifying. This one is actually solving the equation. So as we know, a good part of it's always important to make sure that we get rid of parentheses when we are working on solving or simplifying anything in math. So I've got this equation, 2x times the quantity of x plus 4 plus 7 is equal to the quantity of x plus 8 plus 2x times the quantity of x plus 1 and then plus 12. So it looks kind of crazy. I get that. But you know what? If you use what you know about simplifying expressions, this actually, and you take it little by little, it is solvable. So as you can see, the very first thing that I have here are the arrows drawn. We need to get rid of those parentheses before we can do anything else and get any like terms in there. So when I do that, I've got 2x times x is 2x squared. I've got 2x times 4 is 8x. Now, I will say this. One thing that you probably notice is that I did not write out the step where I'm showing that 2x is being multiplied by both things inside the parentheses. Feel free to do this step if that helps you make sure that you have everything taken care of with multiplication. Okay. There isn't anything in front of this x plus 8, so we bring that down. And then the same thing here, 2x times x, and then 2x times 1. And then we don't multiply by the 12 because that 12 is not inside parentheses. So then what you do is you take a look at this and you say, okay, is there anything I can simplify on the left side? Nope. Is there anything I can simplify on the right side? Yep. I've got x and 2x. When I put the x and the 2x together, that gives me 3x. And then I've got a positive 8 and a positive 12. So that gives me positive 20. So like we said, on the left-hand side, there's nothing else to simplify. So I bring that 2x squared plus 8x plus 7 down. And then on the right-hand side, we've got 2x squared plus 3x plus 20. Now again, notice I've written this expression on the right-hand side in order from the largest exponent down to the smallest. That's intentional. It's not wrong to write it in a different order. This is just one of those, it's nice of you to put them in order if you can. From here again, remember we're solving this equation, so that means we're trying to eliminate things, trying to get x by itself. So the first thing that I notice is that I'm going to try to get rid of this 2x, the 2x squared. And since it's positive, I'm going to subtract it from both sides. And when we do that, that creates a zero pair. And interesting enough, it eliminates it here as well. Okay, this exponent of 2 is actually something called a quadratic, and we don't know how to solve quadratics yet. We will get there, but for the most part, any variable when you're solving the equations, they should be gone once you get to this elimination part. So on the left-hand side, I've got negative 8x plus 7, and then on the right, I'm going to bring down my 3x plus 20. And then again, the whole goal is to get all the x's on one side and the plain numbers on the other. So the next thing that I'm going to do is subtract 3x from both sides. Again, I do that because I'm always trying to make a zero pair to cancel something out. And then 8x minus 3x gives us the 5x. And so I've got 5x plus 7 is equal to 20. And then again, I need to move this 7 over here. So I need to make a zero pair again, and I'm going to subtract 7 from both sides. So once you get that x squared up here eliminated, the rest of this is actually very similar to what we've already done this year with solving equations. So then on the left, I've got 5x, and then on the right, I've got 13. And then we know that when we have a number next to a variable, it means to multiply. So to undo that, we're going to divide. So in this case, get that box out of the way. In this case, our solution would be x is equal to 2.6. Now again, the very first step in here, as with any other expression, in order to simplify or solve, is to make sure that you get rid of those parentheses, and you're always going to do that by using the distributive property. And then your goal is going to be to cancel everything out so that you to get x by itself. All right, what questions do you have about this example? Can you explain it? Of what part, Ymir? This solving equations or, let me go back here, simplifying. Oh, look, I skipped a problem. I sure can show you another example. Great question. Great question, Ymir. Let's actually do example number 2. Thank you, Sam. Let's do this one, Ymir. Hopefully this will clear some things up. So again, we're going to use the distributive property and then we're going to combine like terms. This one maybe example 3 was a bit of a step ahead. I don't know what I was looking at when I did there. So take a minute to write this one down. We've got 15t times the quantity of 10y to the third t to the fifth plus 5y squared t. And then we've got minus 2y times the quantity of y t squared plus 4y. All right, so like we said in example number 1, our goal is to get rid of the parentheses by using the distributive property. You can see I've got those arrows drawn. You're going to give the 15t to both 10y to the third t to the fifth, and you're going to give 15t to 5y squared t. And then also when you do this one over here, we want to make sure that we take along that negative as we distribute. Okay? And remember, we talked earlier this year that when you multiply two terms, you multiply the coefficients, and then you're going to add those exponents of the ones that have the same base. So again, I've got it color-coded for you so you can see the 15t times 10y to the third t to the fifth. Here's the first part. Then the next one is 15t times 5y squared t. Then again, you see I've got this negative here, so I've got negative 2y times y t squared. And then I've got negative 2y times 4y. Again, as I said, once you get to this point, you are going to multiply those coefficients. So that means you're going to do 15 times 10. And then you're going to look, oh, I've got a t and a t to the fifth. And then remember, there's an imaginary one right here. So you're going to add those two exponents. And since the 15t doesn't have any y's with it, you're just going to keep that y to the third. So this first part turns into 150 t to the sixth because this imaginary 1 plus 5, and then y to the third. Then again, 15 times 5 is 75. And then t times t, remember these t's have imaginary ones. So 1 plus 1 is 2. And then there's no other y's, so that's here. And then I've got negative 2. Well, there's no number in front of this one, but let's just remember there's that imaginary 1 there. And there's imaginary 1s with those y's. And then the last one, negative 2 times 4, negative 8. And then y times y is y squared. So once you get here, honestly, this part right here is pretty much all review. Multiplying coefficients and then simplifying terms with the exponents, with what we learned with rules of exponents. Then from here, you look down the line and you say, okay, what else can I do? Is there anything else that's considered a like term? Again, in order to consider like terms, you need to take a look at the variables. Here's t to the sixth, y to the third. I've got t squared, y squared. I've got t squared, y squared. And I've got y squared. Oh, look at that. These guys are exactly the same. They both have the same variables and exponents, the t squared and the y squared. So I'm going to simplify that. And 75 minus 2 is 73. So my final answer for this one is 150 t to the 6th y to the 3rd. That's this first term. And then again, when the variables and exponents are the same, those are like terms, so you just add or subtract. So 75 minus 2 gave us 73. And then I brought our minus 8y squared down as well. So this would be considered the final answer for this one. And again, I know it's completely simplified because the variables and exponents are not the same. So that would be my final answer. All right. Hopefully that helped you, Mir. So here's our closure for today. I want you to think back to those 3 examples that we talked about, and what's either one thing you learned or one thing that you were reminded of about simplifying or solving. So take a moment to write that down, please. Sentence starters could be one thing I learned was, or one thing I was reminded of is. All right. When you've got that closure written, then go ahead and go into Schoology, look for that Lesson 8 folder. You'll see a worksheet there for Lesson 8, and like we've been doing, either print it off or write the problems down on your paper. And then you're going to take a picture and download it to your DUR3 for Lesson 8. Okay, now this is where I'd like to give you a little bit of opportunity, I guess. If you have assignments for your other classes that you have to get done today because the teacher's deadline is today, you can